Hey everyone, and welcome. Today, we're diving into the absolutely brilliant science behind a special class of drugs. Think of them like master keys, designed to precisely control one of the body's most powerful and complicated hormones, estrogen. Let's get right into it. So, our story really starts with a puzzle. You see, the hormone estrogen is a total multitasker, and it's absolutely essential for our health. But here's the thing. Its effects can be wildly different depending on where it is in the body. And for doctors trying to treat diseases, well, that's a massive challenge.
So this is the big question, right? How on earth can one single chemical signal be a force for good in one part of the body, say building strong bones, while at the same time being a potential danger in another, like fueling cancer growth? That is the exact mystery we're going to unravel today.
I mean, just look at estrogen's to-do list. It's huge. It's involved in everything from physical development to keeping our bones dense, and it even helps our hearts by boosting good cholesterol. But, and this is a big but, on the flip side, it also makes our blood clot more easily, which can be risky. It's a classic double-edged sword, and that's what makes trying to control it so incredibly tricky. Okay, so to really get how scientists cracked this code, we need a simple but super powerful analogy, the lock-and-key system. This is the core idea, the fundamental principle that explains how hormones like estrogen work, and, more importantly for us, how we can actually control them. So inside pretty much all of our cells, there are these proteins called receptors. The easiest way to think of them is as tiny, specialized locks. Estrogen, then, is the key. When that estrogen key slides into the receptor lock and gives it a turn, it tells the cell exactly what to do. So you see, it's not just about the key. The lock it fits into is just as important. And this is where it gets really, really cool. It turns out there isn't just one type of lock. There are two main estrogen receptors, alpha and beta. Alpha is pretty straightforward. You turn it and things happen. But beta is more of a modulator. It can work with alpha, and sometimes it can even hit the brakes on what alpha is doing. Now here's the kicker. The number of alpha versus beta locks is different in different tissues, and that, my friends, is a major clue. So now that we've got the locks figured out, let's talk about the incredible toolkit of keys that scientists and pharmacologists have designed. And these aren't just copies of the original key. Oh no. These are sophisticated, super smart instruments designed to play this system with unbelievable precision. And this toolkit is amazingly diverse. You've got your standard estrogens, which are basically perfect copies of the body's own key. Then you have SERMs, these selective keys, and trust me, they are the real stars of the show. We also have keys that can block just one very specific lock, which is super clever. And finally, there are drugs that do something completely different. They just shut down the entire key factory. All right, let's put these clever keys to work. How do they actually help us solve real-world medical problems? Everything from treating breast cancer to preventing osteoporosis and even helping with infertility. This is where all this amazing science becomes truly life-changing. Okay, so let's zoom in on the most ingenious tools in the entire kit, the SERMs. This is where the whole simple idea of an on or off switch just gets completely thrown out the window. We're talking about something way, way smarter. SERM stands for Selective Estrogen Receptor Modulator, and that word, selective, that's everything. These drugs are designed to act as an agonist, which means they turn the lock on in one part of the body, but as an antagonist, which is basically a blocker that gets stuck in the lock somewhere else entirely. This dual personality is just incredible when you see it in action. Look at tamoxifen. In bone tissue, it acts as an agonist. It turns the estrogen signal on. That's great. It helps keep bones strong. But in breast tissue, it's an antagonist. It turns the signal off, which is exactly what you want to fight certain cancers. The one catch? In the uterus, it acts as an agonist again, which can be a risk. But then look at raloxifene. It manages to be a good guy in all three tissues. Amazing. Which, of course, brings us back to that just mind-bending question. How is this even possible? How can a single molecule act like a good guy in one room and a bad guy in another? Well, the answer is this beautiful combination of three different, really brilliant mechanisms. So secret number one, it's about the locks themselves. Remember our alpha and beta receptors? Well, different tissues have different ratios of them. So a drug that's designed to really prefer, say, the beta lock is going to have a huge effect in a tissue that's full of beta receptors and do almost nothing in a tissue that's mostly got alpha.
Secret number 2 is all about shape. When one of these SERM drugs binds to the receptor lock, it physically forces that lock to fold into a completely unique 3D shape. And that shape is different from the shape it makes when natural estrogen binds. This brand new, unique shape is what sends a totally unique signal to the rest of the cell. And finally, secret number 3, it's all about the neighborhood. Every cell has a unique mix of what we can call helper proteins. Some of these are go signals, called coactivators. Others are stop signals, called co-repressors. So that unique shape the receptor folded into, it attracts a very specific set of these helpers. In bone, that shape might grab a bunch of go proteins, but in the breast, that exact same shape might attract stop proteins. It's absolutely fascinating. So, we can pick locks selectively, but what about blocking just one specific lock in one specific place? That's exactly how the drug clomiphene works to treat infertility. It's designed to only block the estrogen receptors in the brain. This totally tricks the brain into thinking estrogen levels are dangerously low, so it panics and sends out this huge surge of go hormones. And those hormones travel down and tell the ovaries, hey, time to release an egg. It's a simple block in just the right place that creates this powerful, positive chain reaction. We've seen how to pick locks and block specific locks. But what if you wanted to take a much more direct approach? What if you could just find the factory that makes all the estrogen keys in the first place and shut it down? Well, that's exactly what aromatase inhibitors do. They go in and they block an enzyme called aromatase. That enzyme is literally the machinery our body uses to make estrogen. So no enzyme, no estrogen. It's a really powerful way to slash estrogen levels across the entire body. And this shut down the factory approach is incredibly important for treating diseases that are basically fueled by estrogen. Things like certain types of breast cancer and endometrial cancer, or really painful conditions like endometriosis. It's a bit of a blunt instrument, for sure, but it is a very effective one when you need to take the fuel away from the fire. You know, when you take a step back and you look at this whole toolkit, what you're really seeing is a monumental shift in how we even think about medicine. We've moved away from brute force and towards this incredible finesse. It's nothing short of a revolution in drug design. This quote just captures the new philosophy perfectly. The goal isn't just to find a master on-off switch anymore. It's to become a conductor of our own biology, to raise the volume of a hormone's effect in one tissue while quieting it in another, creating this perfect harmony that promotes health and fights disease. And that really leaves us with a final and pretty exciting thought. This kind of precision targeting goes so far beyond just estrogen. As we keep mapping our own incredibly complex biological pathways, what other diseases are we going to conquer? What other biological locks are out there just waiting for us to design the perfect key? Thanks so much for tuning in.